Stack. Stack is a linear data structure, or stack is a last in first out list. LIFO. LIFO means last in first out list. A stack is an ordered collection of elements where insertion and deletion of elements is done from only one end. For example, bangles on hand. Suppose you need to insert 3 bangles on your hand. First you are inserting the first bangle, then you are inserting the second bangle, then after that you are inserting third bangle. Then which one is taking out first? The last inserted bangle is taking out first. Okay, that is stack. Last in, first out. That is, which element you are inserting last, that is taking out first. That is, it's like a container. Stack is like a container. That is insertion and deletion from only one end, that is from top. Insertion and deletion from top. One more example, stack of books on the desk. Suppose you need to insert 3 notes. First you are inserting the computer notes. Above you are inserting the economics notes. Then you are inserting the accounts notes. Then which is the last inserted note? That is accounts notes. Then which one you will be removing first? The accounts notes will be removing first. That is, which one is inserting last, that will be removing first. That is stack. That is, stack is last in first out list. And in stack, there is a pointer called top pointer. In top only we are insertion and deletion from this top pointer. Next, memory representation of stack. Stack can be represented using one-dimensional array. That's why in stack we can insert only the same data type elements. That is, we can insert integer elements, means all the in one stack. First you are inserting one integer element, means the remaining elements also should be integer. That is the same data type elements. Stack contains only the same data type elements. If you are inserting character elements, means all the elements should be character. Then this stack can be represented using one-dimensional array. And the pointer called top pointer, and also if the top is equal to null, that indicates stack is empty. If top pointer is equal to null, then the stack will be empty. And there is another variable MAXSTK, that is maximum stack capacity. MAXSTK denotes maximum capacity of the stack. And top is equal to MAXSTK, that is top is equal to max stacks, means that indicates stack is full. Stack is empty means that is called stack underflow. Stack is full means stack overflow. Stack overflow means stack is full. Stack underflow means stack is empty. And in the insertion operation, top is incrementing by 1. And in deletion operation, top is decrementing by 1. Next we can consider the representation of the stack. See, the first stack is empty. Here max stack is 3. Number of elements is 4, but max stack is 3. See, in this case, top is equal to null. That is, there is no elements in this stack. Top stack underflow. Stack is empty means top will be null. Then suppose you need to insert one element 10. Then for that you are incrementing the top. That is, top is equal to 0. First top is equal to 0 and in that position you are inserting 10. Next, one more element. Suppose you need to insert one more element 20. For that, top needs to increment by 1. First top was 0. Then top is incrementing by 1. Now the top position is equal to 1. And in that position, we can insert 20. Then suppose you need to insert one more element 30. For that, again you need to increment the top to 2. That is, top is equal to top plus 1. First top was 1. Then that is incrementing to 2. And in that position, we can insert 30. That is, now first we have inserted 10, then 20, then 30. Then here, which is the last inserted element? 30. So, in the deletion process, next deletion process, in that deletion process, which one is deleting first? 30 is deleting first. See, 30 removed from the stack. For that, top is decrementing to 1. That is, top is in deletion operation, top is decrementing by 1. In insertion operation, top is incrementing by 1 and inserting the element. And in deletion operation, top is decrementing by 1. And also, last inserted element is deleting first. That is stack. Next, operations on stack. First is stack. It creates a new and empty stack. Next, push ELE. Insert a new element to the stack. Push means inserting a new element to the stack is called push. That is, inserting one element to the stack is called push. In push operation, top is incremented by 1. And next operation, pop. Deleting one element from the stack or removes the element from the stack is called pop operation. In pop operation, top is decremented by 1. Then the fourth operation, peek. Peek returns the top element from the stack. That is, peek returns the top element from the stack, but it is not removing. The difference between pop and peek is pop removes the top element, but peek is not removing the top element, but it is returns the top element from the stack. Then fifth one is empty. Is empty is for test whether the stack is empty. That is, if the stack is empty, it will return true, and if it is not, it will return false. Next, size. Size operation returns the total number of elements of the stack. These are the operations on stack. Stack creates new stack. Push means insert, pop, delete or remove. Peek means it returns the top element. Is empty to test whether the stack is empty. Size returns the total number of elements of the stack. Next, algorithm for push operation. Push means insert one element to the stack. Push stack top ELE N. In here, stack is the array name. Stack is the name of the array. Top is a pointer pointing to the top element of the stack. ELE is the element to be inserted. N is the maximum number of elements of the stack. Then the step 1, if top is equal to n minus 1, that is, it is implementing using one-dimensional array. So, it is starting from 0 to n minus 1. That is, if top is equal to n minus 1, print stack overflow or stack is full. That is, in the insertion operation, you need to check stack is full or not. If top is equal to n minus 1 means needs to print stack is full or stack overflow. In the step 2, top is equal to top plus 1. And in that top position, we can insert that element. Stack of top is equal to ELE. That is, In push operation, first itself we have to check. We need to check stack is full or not. For checking the stack is full, if top is equal to n minus 1, stack will be full or stack overflow. Then if stack is not full, top needs to increment by 1, and in that top position we can insert the element.